Welcome back. You like what I've done with the place? It's not much, but it's a little more Anderson-y, so I think that's pretty cool. So, we are back in section 2.1, and we've been constructing frequency tables. And as you can see in the bottom corner here, if you thought that you were done with the frequency table, we're not quite there yet. There are a couple additional columns that we can calculate for relative frequency and cumulative frequency. But these columns are not too difficult to construct, so let's talk about what those things are, how to calculate them, and how we can use them to create some graphs. So, starting with relative frequencies here, we're on page 3 of the notes, by the way, in case you can't see it there. I made the notes a little small, but I need my space here. So, relative frequencies, it's how much frequency of the entire data set is in any particular class. So, it's the percent of data the percentage of data that occurs in each class. So, it should be relatively straightforward to calculate. So, for example, we need to calculate some things to get to this. We need to know, for example, for the data set that's in the table here, these are the frequencies. So, if we want to calculate the relative frequency, the percent of data that occurs in the first class that has a frequency of 3, we need to know some information. Notably, what's the total frequency? How many values are there in the data set? And this table in particular is coming from the first example that we used in the notes for this section. So it's the basketball scores. So to find out how many data values are in this data set, we just add up all the frequencies. So that's 10, 20, 30. There are 30 values total in this data set. So to calculate the first relative frequency, we're just going to take 3 over 30. So 3 over 30 equals 0.1. So I call it a percentage. Relative frequencies are usually reported as decimals instead. But you know, percentages and decimals mean the same thing. But if we're going to be turning these relative frequencies into part of a graph, which we're going to be doing later in this video, it'll be easier if these are in decimal form. So I've written the fraction and the decimal here just to show you where this decimal comes from. You don't necessarily, when you're filling out a frequency table, need to write that entire equation. You can just write the decimal. But for your own purposes, it might be helpful for the first one or two to write the fraction that gives you that decimal. So to calculate the relative frequencies for each class, what you would do is take so relative frequency equals the class frequency divided by n, which is going to be the total sample size. N is the sample size. We statisticians don't really have notation for a particular class's frequency. I guess we could call it N1, N2, N3, N4, but that might be confusing. So just take the class frequency over the sample size, and that will give you your relative frequency for each class. So what I would encourage you to do, go ahead and calculate the rest of the relative frequencies if you haven't done so already. Turn them into decimals, complete that column of the frequency table. These are the values I get for the relative frequencies. I rounded them to 2 decimal places. It's not really going to be very helpful to take this all the way out to like 10 decimals. 2 is fine. 2 is probably enough. Something you should probably check before you go too far, what should these all add up to? 1. They should add up to 1. So you might want to take a second and make sure that's the case. We've got 20, 40, 60, 70, 80, 90. Yes, 100. Now, if you're going to be rounding some of these values, it may add up to like 0.99 or 1.01 or something like that. That's okay because it's due to the rounding. But it should be either exactly 1 or pretty close to it. So that's relative frequency. Easy enough. All you need in a frequency table are the frequencies for each column, and you can calculate these. Pretty simple. Cumulative frequencies also aren't that bad. The word cumulative, you may know what that means. It's related to the word accumulate, which means to add up. So the cumulative frequencies, we're essentially just adding up the frequencies as we go for each class. Pretty simple. So this is the sum of frequencies up to and including that class. Up to and including that class. Okay. So, at the very bottom on the notes down there, right before the frequency table, it says the first class's cumulative frequency is. So, if you're adding up as you go along, I guess the question is where you start. And for the first class's cumulative frequency, it's just going to be equal to its frequency. So the first one here is going to be 3. So first class's cumulative frequency equals its frequency. And for every subsequent class, we're going to add that class's frequency to the prior class's cumulative frequency. So, 3, we're going to be adding 7 here to make the cumulative frequency 10. So up to and including everything in the second class, we've got now 10 data values. The next one, we're going to be adding 7 more to this value. So we always start with the value that's in the cumulative frequency and add the next frequency. So this is going to be 10 plus 7, which is 17. If you can continue the pattern, go ahead and do it. Those should be the values you get for your cumulative frequencies. And a nice thing to check when you're done with this column is that your last cumulative frequency should be equal to the sum of all the frequencies, since all you're doing is adding them up quite literally on that column. So, to calculate these cumulative frequencies, you take the prior cumulative frequency plus the current class frequency. So I wrote these out here just to remind myself of how I got these values. If there's a class that has a frequency of 0 somewhere in there, that's fine. That just means that you'll have 2 classes that have the same cumulative frequency because you're not adding anything, for instance. So that, some people are confused by that sometimes. It works the way you would expect. There's nothing special about a frequency of 0. So, this now, if you include these last two columns, I promise, that is a completed frequency table. So, there is still more to this video, as you might have noticed, but I want to give you a heads up. The homework for section 2.1 is 3 problems. You can see it on Canvas, I've linked it there. 3 problems, but each problem is going to ask you to do a lot. What I would suggest, one thing that each of the 3 questions asks you to do is to construct the frequency table from the original data set. We now know how to use and calculate all of these columns. So what I would recommend when you're done watching this video, if you've got some time, go ahead and start the 2.1 homework and construct the completed frequency table for all 3 of those questions. Then, as you learn how to do more things in this section, you can add on to what you've done for the homework. If you wait to do it all until the very end, it's gonna take a while. Going through the whole process, making the table, getting all the graphs done that we're gonna be learning about here, it's gonna take a while, and I don't want you to hate me, and I don't want you to be late turning it in. So, start the homework as soon as you can. Construct your frequency tables for each of those 3 problems. Actually, by the time this video is over, you'll be able to make a couple graphs for each problem as well. So get started on that. So, let us actually, now that we have a completed frequency table, what are we going to do with it? What are we going to do with all this wonderful information about this data set? We're going to make graphs so we can see what the data set looks like at a glance. People love pictures. So let's turn this table with all of its data into some pictures. I'll need to clean this out a little bit though, so give me a second. All right, much better. All right, we got some room to work with now. So, I've added a column to the table that was here earlier in the video that includes the class boundaries, because that column is going to be important for us to do these things. We're going to create 2 graphs from the information in a lot of our frequency table. And the first graph we're going to make is a basic histogram. What makes it basic? We'll find out in just a sec. But we're going to follow the steps that are right here. And it tells us everything we need to do to make a complete histogram that has all the pieces. All the pieces. If you think that you know how to make a histogram already, fine, you maybe do. But what's important to me is that all the pieces are there. Because if some of the pieces are missing, or any of them are, someone's going to be confused when you give them that graph. They're not going to know everything about the data set that you want to explain. So, here we go. First things first, any graph you make in this class, I don't care what kind of graph it is, needs a title. Without a title, your graph is a big question mark. What is the data about? No one's going to know. The title is what tells everyone what the picture is about. It is the most important thing about the graph. So, if we're going to be using the example 1A data, which is the same data that we were just working with in this table, it's the basketball scores. A good title is specific. It has details. So instead of just saying basketball scores for the title, I'm going to be a little more specific. Winning scores of 30 NCAA basketball teams with the date, February 16th, 2019. By reading that title, you know exactly what this data is about. It's not just scores of teams, it's winning scores. How many teams were involved? It's right there in the title, 30. Were they pro teams? No, they were college. This is an acronym for NCAA, specifically men's basketball. And when did it happen? February 16, 2019. All this data was from this date. So that is an important part of the data set as well. I will never, if you have to create a graph for a quiz or test, which you'll have to do several times this year, I will never penalize you for a title that is too specific. I would rather you write a extremely long title that gives a bunch of detail than to just write scores or basketball scores. That's not specific enough. Okay, give your data justice. Every part about this title is useful for people to understand what the graph is about. So, hopefully I've explained that fully, and on the next quiz that I give, I will be able to determine who watched this video, at least to this point, and who didn't. Because the people who didn't are going to have bad titles. So, let's see, that's step one. Step two. Oh, we need to make our basic L shape here. Okay. All the graphs we're going to be going through in this section and creating are going to have this basic L shape. Step two is to label the axes. So we want to say what is being graphed along the X and Y, or horizontal and vertical axes. And it says the vertical axis is frequency. Oh boy. I had to write it really small there. It says frequency. Okay, I can't rough up my new border. My wife would get really mad at me. So this axis for a basic histogram is going to be frequency. That's what we're going to be graphing on this axis. That's what makes it basic. The other type of graph we're going to talk about is a relative frequency histogram. You might be able to figure out what's going to go on that vertical axis for this histogram. Relative frequency. But here, it's going to be these numbers, the frequencies themselves. So, what is it that goes on this axis for a label? Well, it's whatever the variable is. Now, if your title is good, people know what the data is. So you don't have to be super specific down here. You can just put winning scores. That would probably be enough. I think that's fine. Okay, you do not need to put everything in the title down in this label. But what does not go down here is class boundaries, which is what so many people put down here for a label. Yes, that is what's going to be the values here. But this label should tell you what the data is, not class boundaries, right? This axis label should be different for every graph that you make. So, that's step two. Step three, write the frequencies on the vertical axis. Cool, good. So we actually need to look at our table. So I've got this part of the table here. And I'm trying to figure out on this axis how high I need to go. What number is going to go at the top? And the natural thing to do would be to look at what's the largest frequency, what's the highest value. And we see it's 8. So I need this number to be at least 8. At least 8. It could be bigger if you want, but I think for this particular data set, 8 is fine. 8 is fine at the top there. So we need to scale the rest of the axis so that 8 is the number on top. I like cutting things in half if I can. So I'll go about halfway up, call that 4. And I can cut each of those in half again. So this would be 2. This is 6. And if I want, and I feel like I have enough room here, I can even cut each of these in half to make the odd numbers. 1, 3, 5, and 7. The way you scale your axes is ultimately up to you. The main thing that you need, the highest value needs to be able to capture all of these numbers. Okay, don't make that number too small. But how you break it up is up to you. I feel like just putting 4 and 8 is not enough. But if I had left it at 2, 4, 6, 8 without the 1, 3, 5, 7, I think that's fine. It's really up to you. To some extent, making this graph the way you think is best is an art, not a science. I'm just giving you guidelines here. So, we've got our vertical axis. Cool. Step 4 is to write the class boundaries on the horizontal axis. So, the class boundaries we came up with for our frequency table, they were based on the class limits, if you remember. So we're not directly using the class limits here, but we use those to get these numbers. And each unique number that's on here is going to be graphed on this axis. Starting with the smallest one. The first lower class boundary here is 65.5. So that's going to be the first number here. Every other unique number in this column is going to go here. So the next one's 71.5. This is also 71.5. It's not like we're going to put it there again. 77.5 is next. 83.5. 89.5. 95.5. 101.5. Okay. So all of the values in the class boundaries column have been graphed here. These should be approximately equally spaced because they're all 6 apart, right? It doesn't have to be perfect. I know there are some of you out there that you're going to want to take a ruler to this and make sure everything's perfect. I'm not going to require perfection on these graphs. It's just a sketch, okay? If you're a ruler type of person, I can make your life a little bit easier and recommend that you do this on graph paper. It's much easier to make everything straight on graph paper than regular lined paper. Just a tip for you. That's not necessary here. It can be a little messy, goodness knows. See in art. It's not going to be perfect. Okay. So, we have labeled and scaled both of our axes. So we're on step 5. Let's draw some bars, shall we? It's the whole point of this, right? Let's do some bars here. So for each frequency has class boundaries that go with it. So from 65.5 to 71.5, which is going to be this, the frequency is 3, which is here. So we draw a bar that goes from 65.5 to 71.5 and goes up to 3. By listing all the steps like that, it makes it seem more complicated than it is. You're essentially just drawing bars that go up to the frequency. Okay. Your second class, 71.5 to 77.5, has a frequency of 7, so it will go much taller. Those bars don't even look straight close up. It looks worse the further back the camera is. Your bars are gonna be better than mine, so yeah, we'll just go with that. But you can finish the rest of this graph by going making your bars as tall as each of these frequencies. So the next one is also 7. I'm so embarrassed. It's so bad. 8 is gonna be our tallest bar here. 3 and 2. Perfect. Well, not perfect, but good enough, right? And that is your completed histogram. It needs to have all the right pieces. And if you construct this graph in the order of steps that I've provided in your notes, you won't miss anything. If you go straight to drawing your L and making bars, you might forget the title and axis labels. I don't want you to forget those things. So, I would recommend starting with the title, draw your L, label your axes, then scale, then do the bars. Then you won't miss anything. And again, I'm telling you, so I will be able to know who watched this video. The most common mistake I see is right here. People label this as class boundaries because that's what they see here. What's being graphed, these represent the frequency of the scores. How many teams that won a game scored between these values. There were 3 teams that won on this date that scored between 65.5 and 71.5 points. There are only 2 that scored between 95.5 and 101.5. Okay, labeling this class boundaries is not going to help anyone understand what this means. Okay. Awesome. Basic histogram has frequency on the vertical axis. What you're going to find, the relative frequency histogram is almost exactly the same as the basic histogram. There's only a slight difference. So through the power of editing, let's get a little bit further than a blank slate here. Okay, here we go. Same title, because we're dealing with the same data set. Same label and scaling on the horizontal axis. For our relative frequency histogram, we're still going to be using our class boundaries in the same way. But the difference is on the vertical axis. This is going to be the relative frequencies. So we're dealing with this column instead. So to scale it, again, we want to know what's a good value to put up top. What's our biggest relative frequency? 0.27. That would be kind of an awkward value to put at the top here. It'd be difficult to subdivide this if I made it 0.27, so I'm going to make it 0.3. Do you have to do that? No. You could make it 0.27. It would just look weird, I think. I'd be curious what you put on this axis to scale it. By making it 0.3, we're making sure that all of these values fit, but it's not too big. I wouldn't go up to like 0.4 or 0.5, because then all your bars, even the tallest ones, only could go up to like here. We want to use as much of this space as we can to show off how different the data are between bars, between these classes. So I would pick a number as close to the tallest one as you can that is a nice round number. Yeah. Let's see. I'm thinking about how to subdivide this. I could cut it in half, but then cutting it in half again would get kind of icky. So I'm actually gonna cut it into thirds. Call these 0.1 and 0.2. And I feel like this is still kind of a little sparse. It'd be fine this way, but I will cut these in half again and do 0.05, 0.15, and 0.25. That's what I think looks best. Maybe it looks different on the whiteboard than it does in your notes. If your notes are a little more cramped, you might just want to keep it at 0.1, 0.2, and 0.3. But by giving myself this little extra amount of specificity, it fills in the space better, and it's going to help me figure out exactly how tall these are a little better. So, putting the bars in, very similar to what we did here. We go one class at a time. Our first class is still 65.5 to 71.5, but our bar is going to go up to the relative frequency of 0.1. So, I'll go to here. That's our first bar. The second one will go up to 0.23. So I don't have exactly 0.23 on here, but I can make it pretty close. I can't draw straight lines freehand to save my life, but you get the idea. 0.23 again. 0.27. 0.1. And 0.07. We now have two completed graphs, and what do you notice about them? They look exactly the same. If I asked you to describe the shape, the general shape of what these look like, you would have to say the same thing, because they look exactly the same. So what's the point? Why do we have two different graphs if they look exactly the same? It all depends on what you want to highlight about the data, right? It's all about what's on the vertical axis. If what you're interested in is how many teams won and scored a certain amount of points on this date, you're going to want this histogram because what's being graphed here is the frequency. How many teams are in each of these classes? Maybe what's important to you is what percent, what relative frequency of the teams scored in a particular class. And I can say, oh, well, okay, 10% of teams in this sample won, and 10% of the teams in the sample that won scored somewhere in this range. So it depends on whether you want to talk about the number of teams or the proportion of teams. And that can make a difference. Imagine if instead of 30 teams, we had 500 over the course of the entire month of February. This frequency would go all the way up to 500. Well, it wouldn't go up to 500, but it could easily go up to like 100. It might start getting a little more difficult to interpret these. Whereas the relative frequency histogram, the scale would look pretty much the same. It wouldn't need to go much past 0.3. So generally, the larger the sample size is, the more likely you're going to want to create this graph and talk about proportions or percentages. The smaller the data set is, the more easily we are attached to actual counts or frequencies, and this histogram is better. So these two graphs, although they look the same, are telling slightly different stories. And that's why they both exist. I don't want you to feel like this was a pointless exercise. Both of these graphs have their uses. So, I think this video has gone on long enough, so we'll stop here for today. In our next video, there is one more type of graph we can make using our frequency table, and it uses the cumulative frequency column. And that graph actually looks quite a bit different, so make sure you tune in for that one. And we'll also talk about how to describe the shape of a distribution. What can we say about how this looks in general? We'll find out in our next video. So until then, have a great day. We'll see you next time.